Lesson on 8.4 is going to be brief. I'm going to be demonstrating how we find the derivatives of log functions. You will not have to do this every time, obviously, but I want to show you where this comes from. Because we can find the derivative of natural logarithm of x using all of the tools that we already have. It's just kind of a derivation. So we're going to get to what the derivative of ln of x is, and you're going to be able to just use that as a shortcut from now on. But I want to explain to you how we get there. So ln of x, if we start with ln of x here, that is actually, no, is it frozen? How's that? Log of x is actually log of x base e, right? So let's make this equal to y, or something like that. So if I introduce y, now what I'm going to do, really, because this is dy dx, right? It's derivative of this thing with respect to x. So if I let log of x base e equal y, then what I have is I can change it into an exponential, and I can write this as e to the y equals x. Now why is that important? You're going to see how really simple this is, because knowing what we know about e now, remember the derivative of e to some power is the derivative of
itself.
Yeah, it's itself. It's itself. But you got to remember the chain rule if it's not x. So if we take the derivative now of this with respect to x, I get e to the y times y prime equals 1. Now the derivative with respect to x is actually, I kind of mixed up my notations there, but really this is dy dx, right? So dy dx is what I'm looking for, and this is 1 over e to the y. Going back to going back to here, e to the y is x. So what do I have? I have the derivative with respect to x of ln of x is 1 over x. It's really nice and easy. Isn't that cool? I think that's cool. That's like teacher cool. Maybe not student cool, but teacher cool. Okay. So what happens if it's not ln of x? What happens if it's ln of something else? Well, that's no problem. That's no big deal. What's the derivative with respect to x of, let's say, ln of, I don't know, another function u? We just do the chain rule, right? So that is 1 over u times du dx. Or in other notation, this is 1 over u prime, or u prime over u. So really, I'd like to go there. That's a nice and easy one. So the ln of u, the derivative of ln of u is 1 over u times u prime. So just remember the chain rule. So the derivative of ln of x is 1 over x. You remember that, you're good. Derivative of ln of 2x squared is 1 over 2x squared times the derivative of 2x squared times 4x, right? And you can simplify and all that. Good? We'll do some more examples later. But let's move on from there, and let's say, well, how do I find the derivative, the second part of the lesson? How to find the derivative of an exponential function. Any exponential function. I'm not going to focus in on e to the x, because that's easy. But what about if we had 2 to the x, or 3 to the x, something like that? Well, let's figure out how we do that. Okay? So what's another way we can write b to the x? b to the x, we could write this in terms of e as a base and ln, just like we've learned in chapter 8.3, right? So what I could is I could rewrite b as e to the power of what? Ln of b. So b is actually equal to e to the power of ln of b. Okay? And again, this is just, I'm just showing you sort of where this comes from and how we can use what we already know to find out what the shortcut will be for this coming up. So if we did this, okay, the next step would be to say, all right, I am going to try to find this. E to the ln of, b times x. I'm going to find the derivative of that. Well, notice that this right here is really a constant, isn't it? So, okay, so let's think about this as a whole term, though, yet. Okay, the ln of b is also a constant, right? It's a constant times x. So the derivative of e to anything is itself e ln b times x times the derivative of the ln b times x, right? And so here's what I'm saying. This is actually a constant. So this is e ln bx times x times ln of b. Because remember, it's just a constant times x. Take the derivative with respect to x, you just get ln b. So now we substitute here back in. You see this up here? So this right here is actually the same as this up here, which is actually, yeah, b to the x. So I get b to the power of x times ln of b. So it's very, very similar to the derivative of e to the x. The derivative of e to the x is itself the derivative of b to the x. And I think we kind of did this a little bit the other day, right? What's the derivative of 2 to the power of x? Well, it's 2 to the power of x times some constant. Remember we actually said in the lesson the other day that that little constant is always ln of the base. Remember that? It was back in the last lesson. I showed you that clip of that YouTube video. Okay? So the derivative of 2 to the power of x is 2 to the power of x times that little constant, which is actually ln of 2. Okay, so you might remember that. Let me see if I can find it here real quick. I don't know if I have it back here. Just really easily accessible. But this is sort of what we did the other day, and boy, oh yeah, it was something around here. Look at that. See this? Remember these little constants? That's actually ln of 2. I didn't tell you back then because we didn't know what ln was, but that's ln of 3. And I showed you a little bit of that if you watch that video from last lesson. Okay? Cool, hey? So that's how you can find the derivatives of ln of x and b to the x. One more thing here. We're going to figure out what is the derivative of log of x base b, any base b. So we can do similar things. B to the power of y is x. If I just let this whole thing equal y, right? B to the power of y equals x. So really what we could do is we could find the derivative of this whole thing here. So the derivative of this right here, the derivative of b to the y, yeah, grab that door, thank you, is b to the y ln b, right? Or actually it's b to the y, yeah, b to the y ln b, and this is 1 over here. The derivative of x is 1 because it's with respect to x. Okay, you with me so far? So now, what am I missing? I'm missing a chain rule here. So I need to multiply by a y prime there. So y prime is equal to 1 over b to the y ln b. Okay, and I go back to right here, and b to the y is actually x. So y prime here is 1 over x ln b. So the answer to this question, what is d dx of log of x base b? Well, it's 1 over x ln b, because this was the y over here. Okay. So this, like I say, this derivation, again, this is a bit tricky. You know, I wouldn't worry too much about it. You do have to remember what we ended up with here. These important things, right here, right. The derivative b to the x here, and of course the derivative of ln of x. So you remember those important things. That's what we're aiming for here in this lesson, and we'll do some examples as well. Okay, any questions so far? All right. So I've got some questions and answers right here. So I'll just walk you through them. Okay. I'll just leave these up so you can look at them at your own pace while I'm talking here. But if we had to find the derivative of this right here, that's x squared times ln x. We have to do a product rule here. Okay. 2 x functions, an x squared function, ln of x function. So the derivative of the first is 2x times ln x plus the first times the derivative of the second. Well, we just learned that the derivative of ln of x is 1 over x. When you multiply this together to simplify, you get plain old x, and you can't simplify this any. I think I accidentally erased this x here. So 2x ln x plus x. You could factor an x out if you really wanted to, but you don't have to. Okay? That's for A. Okay, so I'll do each of these step by step with you. All right, so for C, we have ln of x squared, x cubed plus 1. So there's an outer function there, and then there's an inner function. You see that? Okay, outer, inner. So chain rule, yeah. The outer function is ln of something. So the derivative of ln of something is 1 over that something times the derivative of that something, right? Now we've got to times the, yeah, it's chain rule. So this is 3x squared. Okay? So again, the derivative of ln of something is 1 over that something times the derivative of the something. And so that's, yeah, so 3x squared over x cubed plus 1, looks like, for C. So we're doing product rule, chain rule, power rule, and then these new ones that we've learned today. Okay? And E is the other one I have up here just for curiosity's sake here, right? Sine of ln of x looks really complicated, not a big deal. Outer function is sine, so y prime here is, what's the derivative of sine? That's cos, and of course you leave everything inside alone at first. Then you would multiply by the derivative of the inside function, which is just 1 over x. So that's the same as cos of ln of x over x. It's the same thing. All right. Now I have some other examples here, which maybe we'll get to in a bit. Yeah, we need to know all that right now. Okay, so here's your assignment. You can, in your textbook there, you can write that one down. And I'll just run through real quick here. Run through your textbook with you here real quick. Oops. So, number 1. So I might do an example of a log derivative too, if you would like. So just around this lesson, let's do one log function here. So let's do A. So if we're to find the derivative here, f prime of x. So what's the derivative of log again? You remember that? So the derivative of log of something base something is going to be 1 over x ln base. So the derivative of the outside function is going to be 1 over x ln 2. Okay. But this x is actually this in here, isn't it? So this is actually x squared plus 1 instead of just x here. So that would have to change to x squared plus 1. Right? If that was x, this would be x. That's x squared plus 1. Then we multiply by the chain rule there, or by the derivative of the inside, so that's times 2x. So that becomes 2x on top, x squared plus 1 times ln of 2 on the bottom.